For this lesson we have two main objectives. We want to be able to find the values of the 6 trig functions of an angle and find the trig function values of quadrantal angles. When we're looking at the trig functions here, what we are considering is if we have an angle in standard position that will have the initial side on the x-axis, terminal side created by that angle theta, we can really form a right triangle by connecting from the origin and making a right angle and then up to any point really on the terminal side. It does not matter if that point is all the way out here or if it's closer. Again, similar triangles make it so that our trig ratios all end up being the same no matter if the point is out here or further or closer to the origin. Now we have our 6 trig function values here. Notice that if we have our sine of theta here, again really then from this angle y is the opposite, r is the hypotenuse of this right triangle. So we can still use that SOHCAHTOA trick. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we can still use those same trig ratios. And then the other 3 trig ratios we have are the reciprocals. So the reciprocal for sine is cosecant, so notice we just flip y over r into r over y. We have secant, which is the reciprocal for cosine, so instead of x over r we have r over x. And the cotangent is the reciprocal for tangent, so instead of y over x we have x over y. You may also notice that for 4 of these trig functions, they mention that something can't equal 0, so either x can't equal 0 if x is on the bottom, or y can't equal 0 if y is on the bottom. And so that happens in these 4 trig functions. You might wonder why they don't bother to say that r can't equal 0, and the reason for that is because since r is this side, r cannot be 0, so they don't need to mention it, whereas x or y could be 0, and we'll take a look at that when we figure out the quadrantal angles. Let's go ahead and take a look at an actual question. So, looking at the question here, if the terminal side of an angle that's in standard position passes through the point 815, so if I just tell you that it goes through that point 815, now if you don't have a sketch out, I highly recommend sketching that out yourself. But if you have that point 815, then we can figure that if we make a right triangle here, that this side would be 8 and this side would be 15. So again, really your x being 8, y being 15. And again, writing that out is something I would also highly recommend. And then mentioning here how to find r. Really this is the same as the Pythagorean theorem, saying that a squared plus b squared has to equal c squared. But in this case, instead of a, b, and c, it's x, y, and r. And instead of having c squared, we already square root both sides to get the square root of x squared plus y squared. So nothing super fancy there. It's just already ready for us to use, but really just the Pythagorean theorem. So with an 8 and a 15, squaring those, adding those together, and taking the square root, we get 17 for r. Once we have all 3 of those values, it's really just a matter then of determining what the 6 trig function values are. So the sine of that theta is going to be, again, the y over r, so that would be 15 over 17. The cosine of that theta would be the x over r, x being 8, so 8 over 17. And the tangent of theta being y over x, so 15 over 8. You may want to write those 6 trig function values from the previous slide, just to have easy reference. Of course, I suppose you have your slideshow with you, so that would be helpful as well. From there we have the, again, other three trig functions, the ones that are the reciprocals. So again, reciprocal for the sine is the cosecant. So just the reciprocal, so 17 over 15. The secant of theta being 17 over 8, and the cotangent of theta being 8 over 15. And again, you can look at those as the r's and y's, or r's and x's, or x's and y's, but again, also just considering that those are the reciprocals for the kind of basic three trig functions. So just flipping over 15 over 17 becomes 17 over 15. So that's how we can find the six trig function values given a point that lies on the terminal side. Here's another problem with really the same setup. We're given the point on the terminal side. Notice, though, this point is in the third quadrant. On the previous slide we were working in the first quadrant. So in the third quadrant, if the terminal side goes through -3, -4, then x ends up being -3, y ends up being -4. Notice the r is a non-directional distance, so no matter what, r is going to be positive. Here's what it looks like when we find r. We plug in the x and the y. They both get squared. We add them together, we get 25, and of course the square root of 25 is 5. So we have really all three of our values at this point. And again, if you do not start with a graph, if you're just given the description, I highly recommend drawing that out on your own so that you can see what's going on. From there, it's just a matter of writing out those six trig function values. So the sine of theta, again, being y over r, so -4 over 5. The cosine of theta being x over r, so -3 over 5. And the tangent of theta being y over x, so -4 over -3. The reciprocal trig functions then, cosecant of theta just being 5 over -4. The secant of theta being 5 over -3, and the cotangent of theta. I suppose here we should cancel those negatives out, so it would end up for the cotangent here just being +3 over +4, and again with the tangent really +4 over +3 once we cancel out those negatives. So again, another example of finding the six trig function values given a point that lies on the terminal side. We can also find the six trig function values if we just know the equation of a line coinciding with the terminal ray. They give the example here of if we have the equation of x plus 2y equals 0. Now notice they limit us to just the positive values of x. If they did not limit us to just the positive values of x, the line would go in both directions. So that's a problem because then we don't really have a terminal side. We'd have two terminal sides. So you'll be given something either stating that the x values are positive, so if you're looking at x plus 2y equals 0, then you would ignore this part of the line out here. Or if they say x is less than 0, then we would only look at the part of the line that's over here and not this part for the terminal side of that angle. So pay attention when you are looking at questions like that. If you are looking at the x values being greater than or equal to 0 or less than or equal to 0, makes a big difference. But we still want to graph that line, and then what we would do is from that line we would find a point on the terminal side, and then we're back to right where we were before. So again, let's go ahead and take a look at a question. So here is, again, that same line. We were just looking at x plus 2y is equal to 0, and only looking at the values of x that are positive. Again, if we were also looking at x as being negative, then we'd have a line over here and we wouldn't be able to figure out where the terminal side would be. So, of course, if you're going to graph this, of course, it's going to go through the origin. Any equation that's in standard form that equals 0 will do that. So really, you really just need one other point that is on that line. So depending on how you want to figure that, you could take and write that equation in slope-intercept form, which would be a good idea. If we were to look at that for this equation here, we would have 2y equals a negative x. Divide by the 2, we get y equals negative 1/2 x. Well, from there, we could start at our origin and go down 1, right 2, and figure out pretty quickly that it goes through that point 2, negative 1. Once we can figure out that it goes through that point 2, negative 1, we can use the fact that r equals the square root of x squared plus y squared in order to find the value of r, and again can pretty quickly figure that x is 2, y is negative 1 from this point. So again, if we were to draw that right triangle in there, then we can see, okay, well, this side is 2, this side is, again, really a 1, but we're going to make sure we use the sign there, so negative 1. And then figuring out r, we do end up with the square root of 5 when we figure that. So we have our 6 trig functions. So really, again, just a matter of, once we have the x, the y, and the r, filling in those values. So sine of theta being y over r would just end up being negative 1 over the square root of 5. Cosine being x over r, just be 2 over the square root of 5. And tangent being y over x would equal negative 1 over 2. The reciprocals then, cosecant being the reciprocal of the sine, would be the square root of 5 over negative 1. Of course, that would equal negative square root of 5. And the secant being r over x would be square root of 5 over 2. And cotangent equaling x over y would be 2 over negative 1. Now, 4 of these values are okay. We've got the negative 1/2 is fine, negative square root of 5 is good, square root of 5 over 2 is fine. Well, I should say this one here we'd probably want to just simplify to be negative 2. The two I can't leave like this are the sine and the cosine. Again, it's been a while since we've talked about this, but we cannot leave a radical in the denominator, so we have to rationalize that denominator. What we do then, if you remember how to do that, we multiply, in this case by the square root of 5 over the square root of 5. That will transform that into negative square root of 5 over a 5. Do the same thing with the cosine, multiplied by square root of 5 over 5, and we end up getting 2 square roots of 5 over 5. So always make sure to rationalize your denominators for these. Do not leave radicals in the denominators. And again, we are looking for exact answers only, so do not try to use just the decimal approximation for negative 1 over the square root of 5. So, the second of our objectives today was to find the 6 trig function values of quadrantal angles. So we're going to start by looking at an angle of 90 degrees. So the difference here is if we have an angle of 90 degrees, then we can't really draw a triangle here. Now we still have an x and a y, and r would really still just be the distance from the origin up to this point. Now it's actually easier to find r than on a quadrantal angle. The distance from the origin to this point is just 1. Now we can still use the r equals the square root of x squared plus y squared. It would tell you the same thing. It would tell you that r is 1, but with quadrantal angles it's easier just to look and figure out what that is. So we still have our x, y, and r for this point 0, 1. Actually, I'm going to hold off on writing out the values of those 6 trig functions. We'll just take a look at that in a second. And likewise over here, if we are given, instead of being told it's a 90-degree angle, we might be told something like it's got a point that is negative 3, 0 is on the terminal side. Well, that really makes a 180-degree angle, if you're wondering. And so, same thing, we have our x and our y, x being negative 3, y being 0. R would actually also be negative 3, again the distance from the origin out to that point. So you can see those x, y, and r, so again you can still find those 6 trig function values from there. I'm just going to show you those on the next slide. So for 90 degrees, the one we looked at with the point at 1, 0, you can see that the sine is 1, cosine is 0. Tangent ends up being undefined, and that's because we have y over x, and for the 0, 1, x was 0. Cotangent then is actually 0 because it's 0 over 1. Secant is also undefined, and the cosecant is 1. So again, that's all for the 90. Now for the negative 3, 0, that was actually a 180-degree angle. So we get the 6 trig function values here. Notice for the quadrantal angles, the 6 trig function values are either 0, 1, negative 1s, or undefined. Okay, if you look at each individual row, 0, 1, 0, undefined, 1, undefined, you're going to get 2 undefined trig functions for every one of the trig functions, for every quadrantal angle, I should say. And you'll get a pair of zeros. And you'll either have a pair of 1s or a pair of negative 1s, depending on which quadrant, or whether you're going left, down, up, or right. So, but again, still just going back to the different y over r, x over r, y over x ratios for those. Alright, so hopefully this is enough to get you started on your working with trig function values.